Okay, so here we go. This is section 5.2 in your textbook, evaluating trigonometric ratios for special angles. So I made a triangle, and it's an equilateral triangle. That means it's the same amount on all sides. So I decided to just make it 2 on all sides, because I can choose whatever I want. As long as it's the same on each side, then it's equilateral. So we'll make all sides 2. What are the angles in here? Anyone know offhand? You can post it in the chat, or you can raise a hand and say. Does anyone know offhand what will the measure of those angles will be? Yep, they're going to be 60. Thanks, Emma. So it's going to be 60 degrees for each of them, because we got 180 total. It's equilateral, which means all the angles are the same. Thanks, Tasha, and Emmy as well. Awesome. Yep, so 60 degrees in each of those corners. Okay? So far, so good. Here's our exact same triangle again. Here's what I'm going to do, though. I'm going to cut it in half. Okay? So I'm going to put this bar right here and cut this in half. And now we have 2 right angle triangles, 1 on each side. Now this one is still going to have the 60 degrees. So this one's still going to be 60. But I cut this corner in half, so this one's only 30. Because I cut it in half, right? And this one over here is going to be 90. So here's another triangle. We're going to label this triangle because we're just taking this half right here. So there's our 30. There's our 60. And we know this is 2. And this is half of 2, right? Because it's half of that side. So this is going to be 1. And then this one over here, this side over here, I don't actually know what that is. But I can figure it out, right? I got Pythagorean theorem. Pythagorean theorem would tell me. So I'll say, I'm just going to call this side A. Side A would be the square root of the hypotenuse squared minus the other side squared. That's just Pythagorean theorem. So 2 squared is 4. 1 squared is 1. So 4 minus 1 is 3. So that ends up being square root of 3. Now, square root of 3 is like 1.7 something, 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 something. It's a weird decimal number. I don't want to write a big decimal number. I want to leave it exact. So I'm going to leave that as square root of 3. That's how big that side is. Okay? Just using Pythagorean theorem, that's how I figured it out. So that's going to be the height of the triangle. 30, 60, 90, 1, 2, root 3. This triangle is what we call a special triangle. It's a special one we use a lot in trigonometry. So we can develop special angles from this 60-degree angle. So here's what I'm going to do. I'm going to write out all my trigonometric ratios. I'm going to write out my sine of 60, my cos of 60, and my tan of 60. And I'm going to see what I get knowing these sides of the triangle. Okay, so I'm going to extend my page a little bit here. And let's get this done. Let's start with sine of the 60-degree angle. Let's also do the cos of the 60-degree angle. And let's do the tan of the 60-degree angle. So right now it just looks like I'm doing some basic trig. Sine, cos, and tan, of course I have to look at the sides of the triangle. Sine is opposite over hypotenuse. So let's go back up to our triangle. Looks to me like the opposite side from 60 degrees is root 3. That's the opposite side. And the hypotenuse is going to be a size of 2. So my sine of 60 is going to be square root of 3. That's the opposite side over the hypotenuse is 2. Cosine, same deal. Cosine is going to be the adjacent side. That's 1 because it's adjacent to 60 degrees. And the hypotenuse is 2. So it's going to be 1 over 2 or 1/2. And my third one, tan of 60 degrees. Tan is opposite. That's root 3. Over adjacent, that's 1. So root 3 over 1. And of course, I can just write that as root 3. So I'm actually going to get out my eraser, and I'm just going to write that as root 3, because anything divided by 1 doesn't change. So it'll look simpler if I just write this as root 3. But really, it's root 3 divided by 1. Okay, cool. So looks like I'm all done those ratios. Now I'm going to go over to my reciprocal ratios. That means I need to have cosecant of 60 degrees, secant of 60 degrees, and cotangent of 60 degrees. Now I could look on my triangle, right, and I could say, okay, cosecant is like sine but flipped over. So it's going to be hypotenuse over opposite. But an easier way is just to look at my sine ratio and know that it's going to be these ones flipped. So let's just flip those rather than having to go back and look at the triangle. So that's going to be 2 over root 3, cos of 60. So secant of 60 will be 2 over 1. Well, 2 over 1 I can just write as 2, because anything divided by 1 stays the same. And tangent of 60, how do I flip that one over? It's going to be 1 over square root of 3. Now I actually want to change this 1 over square root of 3, and I want to make it a little different. So I'm going to do a little aside here. So I'm going to write aside, and that just means I'm doing some other work here. And I'm going to take my 1 over root 3, and I'm actually going to multiply the top and the bottom by the same thing. When I do that with a fraction, it doesn't change it, right? If I multiply the top and the bottom of a fraction by the same thing, it's not going to change it. So I'm going to multiply this by root 3 over root 3. The reason I want to do that is because this will clean it up for me a little bit. We don't like having a square root on the denominator. That causes problems. So multiply the tops. 1 times root 3 is root 3. Root 3 times root 3. Reciprocal ratios. I forgot my T in there, but yes. Reciprocal ratios is what we're calling these. Yeah. The cosecant, secant, and cotangent, Emmy, are reciprocal ratios. Root 3 times root 3. That's just going to be 3. Right? That's just going to be 3, because that's basically like squaring it, and squaring it undoes the square root. So I can also write this one as root 3 over 3. And that's a nicer way to write it, because having square roots on the denominator can cause problems. So later you're going to want to write all of these down. Everything in blue, our primary trig ratios and our reciprocal trig ratios, you're going to want to write all of these down for the 60s. Okay? I don't want to dwell on that, but you're going to want to write all these down later, and you'll have full access to this file. This is also in your textbook, and I'll also post extra videos, and this video will be posted as well. But I want to move on for now, because we could also develop some special angles for a 30-degree angle. So if we had a 30-degree angle, I'm just going to kind of set up my triangle here. It's the same one, right? We got our 30 here, we got our 60 here. We got our 1, our 2, and our root 3. So exact same half of our triangle. And now I'm going to write the ratios, the primary and reciprocal trig ratios for the 30-degree angle instead of the 60. So now I'm looking from the 30. So 1 is my opposite, 2 is still my hypotenuse, and root 3 is my adjacent. So here we go. I'm going to write all those up. I'm going to go sine of 30 degrees is opposite over hypotenuse. So opposite is 1, hypotenuse is 2. So that's 1/2. Cos of 30 is going to be my adjacent side over my hypotenuse. Tan of 30 is going to be my opposite side over my adjacent side. And we remember that we can turn that into root 3 over 3. So those are my primary trig ratios for this special triangle if I'm looking from the 30-degree angle. My reciprocal ones, I've got cosecant of 30. That's going to be hypotenuse over opposite. So that's 2 over 1. I'll just write that as 2. Secant of 30, that's hypotenuse over adjacent. That's going to be 2 over root 3. Now, if I do the same thing, I'm going to multiply the top and bottom by root 3 to clean this up. I'll end up with just a 3 on the bottom. And then I'll end up with 2 times root 3 on the top. Some people might say, that looks uglier, but trust me, it gives you problems if you have the square roots on the denominator. This will make a little more sense later how it can cause you problems. And our cotangent of 30 is adjacent over opposite. That's root 3 over 1. I'll just write it as root 3. So there's my next set of special angle trig ratios. Again, these ones you're going to want to have written down with the other ones all in one nice place. Okay, we're going to go to our next setup here. We're going to consider another type of triangle. This is a right isosceles triangle. So I'm going to say the sides are just 1 and 1. Isosceles means we have 2 sides that are the same. So 1 and 1. Well, what does that make this one over here? Well, if we want to find out what it is, we're going to have to use Pythagorean theorem. One squared is 1, 1 squared is 1. This is going to be square root of 2. So Pythagorean theorem tells us that's square root of 2. Anyone think they know what the angles might be? We're only allowed 180. 90 is taken up by this right angle here. What are the other 2 angles going to be if it's an isosceles triangle, meaning the 2 sides are the same length? Yeah, they got to be 45 because they have to be equal. So we got a 45 here and a 45 here. Okay, so that's another one of our special triangles. So let's go to our next page. Let's just reproduce our special triangle. We call this a 1, 1, root 2 triangle. Let's do the same thing as we did before, but using this new triangle. We're going to set up our ratios. So I'm going to move kind of quickly here because I want to make sure we get through this so I can show you how we might use it. So our sine of 45 is going to be opposite over hypotenuse. That's going to be 1 over root 2. Again, we don't like those square roots on the bottom. If we multiply top and bottom by root 2, we end up with root 2 over 2. That's kind of a nicer way to write it. Cosine of 45 is going to be also 1 over root 2. So we can simplify that to root 2 over 2. And tan of 45 is going to be 1 over 1. Well, 1 over 1 is just 1. Easy. Our reciprocal ones, let's flip those over. Cosecant of 45 is going to be, well, 1 over root 2. Flip that over, I have root 2 over 1. You can just write that as square root of 2. Secant 45, exactly the same thing. And cotangent of 45, oh, that's easy. 1 over 1, flip it over, it's still 1. All right. Again, we got a whole new set here of trig ratios that we're going to want to be able to draw on. So we ideally want all of these on one page, in one spot. So building yourself a nice little note so you have them all in front of you, all in one spot, great. Or find them in your textbook and just clip them out as one big one, great. I want to finish off by showing you how you would use this. So let's use our special angles we've developed to find some exact values. This means we don't have to plug these into our calculator and get a bunch of crazy decimals. We can get exact numbers. So if we want to determine the exact value of sine of 45 times cos of 45 plus sine of 30 times sine of 60, we could plug that into our calculator and get a big weird decimal mess. But now that I know what these numbers are, because I figured them out, I can be much more exact. Sine of 45, well, we just saw that on the last page. Sine of 45 degrees is square root of 2 over 2, or 1 over root 2. Either of those will work. In this situation, it's actually going to work out fine for us to write it as 1 over square root of 2. Cos of 45, same thing. We can write that as 1 over square root of 2. Sine of 30, we're going to have to go back a couple of pages here. There it is. Sine of 30 degrees is equal to 1/2. And if you plug that into your calculator, you'll see it comes out as 0.5. So let's write that as 0. Actually, let's write it as a half. We'll keep it as a nice, beautiful fraction. That's what we're here for, is fractions. And sine of 60 is going to be square root of 3 over 2. Let's do some multiplying. 1 times 1 on the top is 1. Root 2 times root 2 is 2. Plus 1 times square root of 3 on the top is square root of 3. 2 times 2 is 4. Now we can't add these fractions together yet. We need the same denominator. So let's change 1/2 into 2/4 by multiplying the top and bottom by 2. Now we can add these pieces together. 2/4 plus root 3/4 is going to be 2 plus root 3. Now you can plug this into your calculator and you're going to get the exact same answer when it outputs it as a decimal as you'd get if you mashed in sine of 45 times cos of 45 plus sine of 30 times sine of 60. But now in this way we have it written as an exact value. Keeps it nice and clean. We can also do a little bit of equation solving. So if we want to use these to solve equations, we can. In this case, I'm going to try and solve this equation. How do I do that? Well, first I'll move this over to the other side. So I'll add root 3 to both sides. And I'll end up with 2 times sine theta equals square root of 3. Now I want to get rid of this 2, so I'm going to divide both sides by 2. That's going to leave me with sine theta over square root of 3 over 2. Oh, this looks familiar. Sine of some angle equals root 3 over 2. Let's go looking. It's not 30. Maybe it's sine of 45. No, that's not root 3 over 2. Here it is. Sine of 60 is root 3 over 2. That's one of the ones we covered. So then we say, okay, so theta must be 60. Because we know sine of 60 degrees is root 3 over 2. Similar for this one. I want to solve this. I'm going to divide both sides by 4. So I end up with tan theta equals 4 divided by 4. Well, 4 divided by 4 is just 1. Is there one of those ratios where the tangent just equaled 1? Sure there was. Tan of 45 degrees equals 1. So I know that my angle must be 45 degrees. Okay, so that's all the stuff I wanted to cover. I know I'm kind of rushed that. I think we need to play with it a bit. We're going to revisit it tomorrow and try and get a bit more practice with it. But what I want you to do tonight, there are some questions that I've assigned that I'd like you to try. See how they go. If you're running into trouble, I want you to send me a message on Edsby and let me know some of the ones you may want me to show and demonstrate for the whole class tomorrow. But give them a try, okay? I know we've gone pretty quick. You're going to need to wrestle with them a bit. But give it a try, and I would also recommend each of those ratios for 30, 60, and 45 degrees. I think you should write all those down in one place. I think you'll be glad you did. So I'm going to stop the video now. Save that.